Okay, fine. Let me also switch off the camera so that there will be no interference. Sorry, what he is asking? Oh, okay. Okay, so what we'll discuss first? We'll discuss first the Java thing, right? Just a minute. Okay, my screen is visible, right? What I'm writing on the screen and all. Okay, fine. Java. So first thing, this session will be absolutely from scratch. Okay, so it I mean, initially you may feel it's all repetitive, but there are some conceptual thing that will be that will be discussed here. So please uh, be there. Okay, so it's not very what I say. It's not that boring. Okay, so Java is a good language. Okay, fine. So, what is Java? First thing, what is Java? Java is a programming language, okay, and a platform. When I am saying programming language and a platform, I have to define it, right? Java is a high level, robust, object oriented, and secure programming language. So, what are the properties here? So, properties are it's high level, high level, okay, robust, object oriented, and secure programming language. So what is high level? See, what is computer? Computer is an electronic device, right? If you see, computer is electronic device. Suppose I am using this laptop, right? What is this laptop? It's an electronic device. Now, what is high level language? Electronic device only understands two languages. Okay, one is high voltage and one is low voltage. Okay, high voltage is denoted as 1 and low voltage is denoted as 0. Okay, so suppose this is your microprocessor, this is your computer. Okay, here is a, we all learned this in digital electronics and in our engineering days, right? So we have all threshold voltage. Suppose this is a 5 volt voltage. So any signal is coming here more than 5 volt is considered as 1, and any signal is less than 5 volt is considered as 0. Okay, this is called the binary code. Other than this binary code, computer, I mean, this is, computer understands nothing, right? But if you, if you are asked to write all these codes, right, all these development codes, testing codes with 0 and 1, that will be not possible. So human understands what? Human understands English. Okay, throughout the world, uh, human understands English. So we need some language, which is like English. Okay, so which is like English. So initially there were some languages like ALT, okay, machine level language, ALT, and then this kind of high level language came. Okay, this is called low level language. These are the mid level language. Okay, MLL, something mid level language. MLL is basically what we use to program our microprocessor in our engineering days, right? Microprocessor or microcontroller. There is move, okay, copy. Those things are like that, one liner commands. Those are again not very human friendly, right? User friendly language. So we need some language which is user friendly, that is English like language. So we discovered, or scientists discovered, first C, okay, then C++, Java. These all are high level languages. Okay, so this English like language will fit to a black box. Okay, and this black box will convert this English level language or high level language to low level language. Okay, so this black box is called compiler. Okay, so what is compiler? Compiler compiles the high level language to low level language or machine level language. Okay, this is an interview question, first interview question. What is compiler? Okay, you can note it down. What is compiler? Right? Now, this is high level. How it is high level, you just understood. It is high level. Now, robust. Robust means when you are writing any program, right, any code, that should be robust. What does it mean? Yeah, anyone is trying to say anything? Hmm. Just a minute. No, I have no request. 3, 4, 5. Don't know. There is no notification basically. Let me. Okay, we'll see. So yes, robust, right? So what do you call robustness? Robustness means, suppose you are writing one particular program, right? That program, without any change, that program can be ran from anywhere. I think that request can, yes. Hey, hi Gaurav. Yeah. How are you? Yeah. Surviving. Yeah, sure. Okay. So robustness means when you are writing a program, okay, a code, piece of code, that piece of code, without editing, without rewriting, without any changes, that code can be ran from anywhere, okay, irrespective of your platform, irrespective of your OS, irrespective of your devices, right? That is called robustness. Ha- it's all very natural, right? So how robust your device is, right? You keep I mean here like this kind of question, how robust your device is, means how kitna mazboot hai wo device, right? Robust means you can use without change, without any modification, anywhere in the world, or any operating system, any kind of devices, right? Next thing is object orientation. Okay, so object orientation, what is object orientation? Object orientation is, see, all the real world data, okay, all the real world data are considered as object. All the real world data are considered as object. Suppose you are moving, right, you are moving some car from here and there. So what is car? Car is again an object. Okay, car is again an object. So likewise in the programming language, any data, suppose some, you are using some integer, you are using some string, you are using some float, double, any data type, those are called objects. The object has some definition, object has some different understanding, but object is basically a base, or you can say um, a, a simple most unit of any programming language, simple most unit of your programming language, which holds some property, which holds some property of any pro forma. Okay, we will discuss what is object, what is object orientation in later section. It will be cleared. Okay, and then secure. Okay, so what is, how it is secure? So if you have learned C language in your in your engineering days, okay, so there is a concept called call by address, where you are calling the address, and by using the star sign you are getting the value of that particular address. But in Java, call by address is not possible, only call by value is possible. Okay, that is why directly you cannot access the address. Okay, you are either accessing the location, or not the address but the location or data or the variable, through some objects or through some other mean, but not the address. So that is why the Java is secure. Any question on these particular 4 points? Any question? Clear? Right. Okay, so for a brief history of Java was first developed by Sun Microsystem, okay, in the year of 1995. It was developed by an engineer called James Gosling, okay, and he is called father of Java. So all these things are good to know. I mean, it's not that. So Java's first name was Oak, O-A-K, okay, O-A-K. The first name of Java was Oak, okay. That time Oak was already registered, okay. Then it was already registered, okay. So Sun Microsystem registered this particular language with Java name, okay. It's all good to know. Now in the definition of Java, I have mentioned two things. One is Java is a programming language, and also Java is a platform, right? Why it is a platform? First thing, what is platform? Okay, any hardware or software, right? Any hardware or software environment in which a program runs. Any hardware or software, suppose this is my laptop, right? This is my laptop. Okay, so my all the programs will run on top of this particular laptop. Okay, so this laptop will be called platform. Now inside this laptop there will be many softwares, many virtual machines. All of these will be called as platform. Okay, platform. So any hardware or software where a program runs will be called a platform. Okay, now Java has a Java runtime environment, and all the APIs we'll discuss later. What are those APIs, what are those environments, right? And also the famous Java virtual machine, JVM, right? So that is why Java is also called a platform. So Java is a programming language as well as platform. Interview question: why Java is called a platform? Just note it down. Right? Any problem in understanding the things so far? Okay, fine. So now is how Java works. So I have already discussed a little glimpse of how Java works. So Java is a high-level programming language. What is high-level programming language? High-level programming language is, just remember this, it's an English-like language or human understandable language. Okay? But as an electronic device, this is my electronic device. This is my electronic device. Okay, this doesn't understand any kind of English. Okay, any kind of English. Okay, this only understands zeros and ones. This only understands zeros and ones, which is the binary values. Okay, so what is what I told? What is binary? Binary is basically nothing but high level voltage and low level voltage, right? For a microprocessor, actually, what we have, what is computer? Computer is a microprocessor, right? What we are seeing in front of us, it's not computer. Computer is the brain of this total device, which is an electronic device. Okay. So then how that high level human understandable language gets converted to low level machine readable language? Okay, so here is, I mean, the Java architecture. Interview question, just describe Java architecture. Okay, describe Java architecture. Describe Java architecture. A very famous interview question. Okay, so first thing, suppose here you have written one Java code, right, in Java language, right? So here there will be a compiler. You are feeding this particular Java code through a compiler. Okay, what this compiler will do? This compiler will convert this particular Java code to byte code. bytecode. Okay, so in Java code is basically you have one .java extension file. Through compiler, after compilation, you will get one .class file. If you open that .class file, you will understand nothing. This bytecode is understandable human, neither understandable by human nor understandable by machine. Okay, this .class file, if you open this particular .class file, you will see all garbage values. Okay, so Java code will compile to bytecode. Now this bytecode will further feed to a Java virtual machine. Okay, here there will be a JVM or Java virtual machine. So what this Java virtual machine will do? Java virtual machine will be fed with this bytecode. Okay, but not directly, through some interpreter. Through some interpreter. What is interpreter? Interpreter is nothing but someone to read this bytecode, this particular bytecode. Okay, this particular bytecode line by line, and tells or dictates those line by line code to JVM. Okay, to JVM. Now, what is virtual machine? I'll discuss it in the later section in detail. What is JVM? But as of now, just consider it. This is also a Java program which will create a virtual machine. There is no physical existence of that particular machine. When you are starting your program or you are starting your code, right, this JVM will pop up, and when your program gets closed or stopped, right, that JVM will automatically destroy it. Okay, automatically destroy it. Now this JVM will further. Now this JVM will execute, I mean all the programs through interpreter. This interpreter is very important. Okay, through interpreter the JVM is executing this program, but executing by what? Suppose you are cooking biryani in your kitchen, right? You will need some masalas, you will need salts, sugar, curd, chicken, paneer, whatever you are eating, right? So all these things are called libraries. Okay, all these things are called libraries. Okay, these particular library will supply all the masalas to cook a biryani. In Java architecture, it is called JRE, or Java Runtime Environment, whose work is, or whose job is to provide runtime environment. What is runtime environment? It's all the libraries. Okay, libraries. Suppose you are reading some files, data from files. For that you need some inbuilt library, correct? So those libraries or those dependencies, those softwares will be given by this particular section where all the masalas are kept, which is called JRE, or Java Runtime Environment. So what is the function of JRE? Provide the runtime environment and all the libraries for the execution, which will be needed for the execution, right? And then what you are seeing? You are seeing the output in the operating system. The operating system is the last layer. Whatever you are seeing in your desk is operating system, right? So here one thing to I mean remember, where the programming is getting executed, the programming, whatever program you have ran, you have created, or whatever code you have created, where it is getting executed on top of JVM, okay, executing all the programs, right, all the codes. So the code is not executing on top of OS directly, okay, it's not related. I mean, OS has some JVM, okay, OS has some JVM, and on top of JVM the code is getting executed. That is why Java is platform independent. Why platform independent? Because it's nothing to do with platform, right? Because the Java code is getting executed in JVM. JVM is a virtual machine. Now this JVM is platform dependent, okay. You will have JVM for iOS, you will have JVM for Windows, you will have JVM, different JVMs for, you know, Mac OS and all other OSs, Linux, right, all other JVMs. So this is how the Java works, okay. And the whole package, right, this whole package is called JDK. JDK, or Java Development Kit. Java Development Kit. Any confusion here? This is very important interview question. Describe the Java architecture. Khushbu, Pritam, any question here? Hmm. Right, right. Correct. The whole thing you have to explain. Okay, whole architecture you have to explain. Now, what is JDK? If you are asked what is JDK, JDK is a combination of JRE and runtime environment. JRE and runtime environment is called the JDK. Okay, and that again. Okay, interpreter is someone who reads this bytecode line by line and feeds to JVM. JVM is not executing all at a time, right? It have to. I mean, that has to be someone who is telling that, okay, execute this line, execute this line, execute this line. Okay, so here one thing, Java is compiling the Java. I mean that .java class as a whole. Okay, it's as a whole. It is converting to bytecode .class file. Okay, it's not line by line activity. Compilation is not line by line activity, but this interpretation is a line by line activity. Okay, is a line. Just remember this very important concept. Interpreter is a line by line activity. Okay, now here the question comes, it's again interview question I used to ask, why Java is called compiled as well as interpreted language. The answer is same. You have to describe this particular architecture. Okay, uh, is Java a completely compiled language? No, right? Because it's compiled language as well as interpreted language, because there is a process of compilation as well as interpretation. Any question on interpreter and compiler? Not understanding what is this? Khushbu? Okay, fine. You just note down all the interview questions I am telling, right? Mm. So we now know how the compiler works, function of compiler, how it is compiled, I mean Java code is compiled, uh, and how human readable code is getting converted to machine readable code, right? Now we'll discuss these basic things, right? This JVM, JRE, right? JVM, JRE. What is JVM? What is JRE? Because these are also important. And what is JDK? We will discuss in detail. Uh, you copied this diagram, or whatever. If you don't want to, that is fine. Can I delete it? Yes, this session is recorded. Yes, obviously. I am deleting this, okay? To get, yeah. Okay, fine. So what is JVM? JVM, I mean Java Virtual Machine. Okay, it's is an applications are called write once, read from anywhere. Okay, Java applications, whatever we are writing. Suppose this is a Java application. Dot Java class we have written, right? This particular Java code can be executed in Windows, can be executed in Mac OS, can be executed in Android, can be executed in Linux, right? Linux. So how it is possible? Because of JVM or Java Virtual Machine. JVM is a virtual machine for executing Java programs. Okay, JVM interprets the bytecode into machine code, which is executed in the machine in which the Java program runs. The process I just elaborated. No? Now this how this particular JVM works. Okay, how this particular JVM works. It's very important. Okay, it's a interview question also, how JVM works and what is JVM. Basically, if you are asked this particular question, what is JVM, don't just say it's a Java virtual machine, right? It's a full form. Basically, you are not saying what is JVM. Okay, fine. So first thing, you are writing your, here you are feeding your .java file and you are getting what after compilation .class file, which is called bytecode, right? Which is called bytecode, that .class file. Now this .class file in the JVM will be loaded into a class loader. Okay, the class loader is a subsystem of JVM. Okay, whatever JVM we have, JVM, what I said, JVM is a again an application, Java application. So it's a subsystem is a class loader which loads the .class file into JVM. Just a mechanism to load the file to the JVM, correct? Now here there will be many things. There will be many things. Suppose we have some method area, method where methods will get stored. Okay, and there will be some heap. This is very important. What is heap? Okay, there will be some stack. Okay, some native stack. Native stack, right? And will be some JVM memory. Okay, so whenever you are feeding your class loader in the JVM memory, right, so there will be some places particular to some of the components. Suppose you have some methods. Okay, I'll describe later what are the methods, what are the things, right? So whatever methods you are writing, those will be come to this method area. Okay, this will be come to this method area. Now heap, what is heap? Heap is a memory location in the JVM. So when we are saying this JVM memory location, what do you say? It's a RAM or ROM? It's RAM or ROM. It's not permanent memory, right? It's a temporary memory. That is why it is RAM for this particular section. So in JVM divides this particular memory or this particular RAM, whatever you have, whatever you have assigned for executing the Java. JVM will distribute it. First is method area, then the class loader will load the heap. Heap means all the objects. Okay, all the objects will be stored in the heap memory area. Heap memory area, all the objects will be stored in heap memory area, because the heap is the area for object storing. Okay, object storing. Okay, now stack, all the variables other than object variables, all the variables like int, like string, float, double, all the variables will be stored in stack memory. Okay, and native stack again, it is used for all the native methods. Okay, there will be some native methods to execute some programs, right? What is native method? Native method which is already in the JDK, already in the libraries. So those methods will be called. So for those you are executing it, right? So you need some space. For that also you need a specific space for where all the native methods will be stored to execute this particular program. So that is why we need some native stack space. Okay, so JVM memory consists of these 4 components, majorly these 4 components, right? Now this, after all this, okay, so this is our JVM memory, right? Now this after this JVM memory, execution process will take place, right? Now this is the native interface. This is called the native interface. Native interface. Why it is interface? Interface will join some components, this JVM memory. Okay, here the native libraries, here all the libraries are coming, native libraries. What is this native libraries called? Anyone? It's called JRE, Java Runtime Environment, native libraries, right? So you are feeding these native libraries to native interface. Okay, and now the execution engine will have one execution engine. Okay, execution, where the program is getting executed. So what are those consist of? First is JIT compiler, just in time compiler. Okay, second is garbage collection. I'll tell what is JIT compiler, what is garbage collection. Okay, so all these things are comes under execution engine. Execution engine consists of two components, JIT compiler and garbage collector. Clear? Now I'll discuss the two process, very important process. What is garbage collection first and what is JIT compiler. First is garbage collection, GB, garbage collection. What is this? Now all the in the JVM memory where all the objects are getting stored inside heap memory, right? We already discussed inside heap memory, right? Any question? I mean, am I going very fast or is it understandable, not understandable? Can you please give some feedback? Okay, so everyone is understanding, right? Khushbu? Okay. Okay, so all the objects, right? Object is what? Or I have already told. Object is smallest unit which holds some property. Okay, it's basically data. So all the objects are getting stored in heap memory. So how objects are created in Java, I'll give you in detail, but for your understanding purpose, this is your class name. Okay, class name. Then object variable, suppose ob equal to new, the same class name. Okay, this is the object things. So what is class, what is object, we'll discuss later in detail. So for now, you see, this is a class name. Okay, where we are creating this object. That means this particular object will hold all the properties inside this particular class. Okay, and new, this new keyword is the keyword which will create the object. Okay, so new keyword will create the object. This object will be stored in this particular variable. This is called object variable. And without this object variable, we cannot access this particular object. Object variable is basically where in the memory location, okay, where in the memory location this particular object getting stored. Okay, this is the variable. Suppose in this location this OB is getting stored, and this is assigned with this particular new class name value, right? Now again, if we are doing some like new class name will itself create an object. We do not need this particular object variable if you do not want to use this particular object. Okay, if you want to use this particular object, then we have to declare this particular object variable. Otherwise we can create objects, I mean, without variables also, right? Without variables also we can create objects, but that is unusable, non-usable. You cannot use that. Okay, where it is storing, how it is storing, it's not getting a very I mean, it's not usable basically. Okay, so for that, those objects are always will store in heap memory. Okay, objects will store in heap memory. Now in heap memory, if JVM encounters any such object which has no object variable, if heap memory encounters any such object which has no object variable, okay, Java or JVM has an internal system to clean that heap memory automatically. Okay, clean that heap memory automatically. This is called garbage collection. This process is called garbage collection. Okay. So what is garbage collection? Garbage collection is nothing but cleaning up heap memory. Okay, cleaning up heap memory. Right? So whatever objects you are assigning or whatever objects you are creating during the course of execution of that particular program, okay, those objects will be go to heap memory. And if heap memory or JVM finds any object without any object variable, that will be automatically cleared. The process of these is called garbage collection. The process of these is called what? Garbage collection. Any question on garbage collection? See, where the objects, suppose you are creating one object, where those objects are getting stored, only objects, not object variable, okay, only objects. So suppose new, your class name is car, so this new car, where it is getting stored inside JVM? It is stored in heap memory, right? Heap memory. Now in this particular heap memory, the heap memory is basically a limited store. Suppose heap memory is your home, right? You have all unused newspapers or unused Amazon boxes, unused everything, right? Which you will not use anyway. What you do? You just throw it to the garbage, right? As a garbage, you throw it और भंगर वालों को बोल के उसको बेच देते हो, correct? So what you are doing a process of cleaning up the memory or cleaning up your house. The same way heap memory is a home, okay, or place where all the objects are getting stored. Now all of the objects are not useful, especially the objects with no object variable. The objects with no object variable, the objects with no object variable will be not useful. Okay, there is no meaning of storing those objects, right, in the heap memory, and I mean you have to free it up somehow. That process, that freed up process, is called garbage collection. क्लियर नहीं हुआ तो बोलो, फिर से मैं समझाऊंगा. फाइन, JRE क्लियर करो. Sure. So what is JRE basically? आप किचन में खाना बनाते हो, राइट? रोटी बनाते हो, सब्जी बनाते हो, जो भी है, दाल वगैरह कुछ बनाते हो. तो इसके लिए क्या चाहिए आपको? चाहिए सॉल्ट, आटा, राइट? आपको राइस चाहिए, ऑल द मसालास. तो ये कहाँ से आप ये करते हो, अरेंज करते हो? आपके किचन में एक शेल्फ है, राइट? जैसे बुक शेल्फ होता है वैसे किचन शेल्फ होता है, तो उसमें आप सारे मसालास रखते हो, राइट? मसाले के डब्बे. This acts as a library of your cooking. This is your gas stove, okay? This is your burner or whatever chula you are using. So you are you are executing your cooking process with the help of these particular libraries or these particular masalas. This is JRE. Okay, this is JRE. Now what here it is, suppose what we discussed, it's a JVM memory, right? JVM memory, where all the bytecodes are getting stored in different way, right? In method area, heap, stack, what we discussed right now. So in from JVM memory, now there would be some, here it is getting stored. Now you have to execute it, right? You will have one native interface. You will have one native interface. Okay, in this native interface you will have these JRE. Okay, these libraries will be fed to native interface, and this will go to your execution engine where your code will get executed, right? So this is consist of two things. One is garbage collection, what I just discussed, and another is JIT or just in time compiler, JIT compiler, right? What is JIT compiler? I will discuss now. This is the execution engine of JVM, execution engine of JVM. Here all the execution happens. Here you have stored all the masalas, rice, roti, rice, gehu, everything, rice, atta, everything. Okay, you are getting all the masalas from here and you are cooking here. This is the execution engine. ये आपका कुछ मतलब कॉरिडोर स्पेस टाइप का आप सोच सकते हो, जहाँ से आप खड़े होके कुछ जैसे मसाला लिए, कुछ शुगर वगैरह लिए, वहाँ से आटा लिए, वहाँ से राइस लिए, एंड देन यू आर कुकिंग हियर. Consider this as chula, okay, chula of the kitchen. Clear? This is the whole process of JVM. The process is called, the whole process of JVM, how JVM constructs. Any question, any more question, Pritam? Okay, now next thing is what is just-in-time compiler. Because in execution engine we have discussed about garbage collection. Now next thing is just in time compiler. Okay, just in time compiler. So we already knew the whole compilation process, right? We already knew the whole compilation process. The JIT or just-in-time compiler is a part of the runtime environment. Okay, it's a runtime environment. It's a part of JVM. It helps in improving the performance of Java application. It helps the performance of the Java application by compiling bytecodes compiling bytecodes to machine code at runtime. So what was the process earlier? The process was like, there will be bytecode, right? There will be bytecode or .class file. Okay, after compilation there will be bytecode, and then again it will feed to interpreter, right? Interpreter will feed to JVM. Okay, and JVM, in the JVM process, suppose here is the execution engine inside JVM. But in case of just-in-time compiler, JIT, this bytecode is again compiled. Compiled means it's a one-time activity. Okay, again compiled and saved in execution engine directly. The interpretation process is omitted. The interpretation process is omitted in case of just-in-time compiler. Okay, so it the application by compiling, the performance of the Java application or Java code will be improved by compiling the bytecode to machine code at runtime. Okay, there will be no process of interpretation, right? The JIT compiler is enabled by default. It is enabled by default when a method is compiled. Suppose you have a method, okay, you have a method. So where your method will get saved? Your method will get saved in the method area, right? In the JVM memory method area. So how these methods will be compiled? So those methods will be compiled directly, not through interpreter. Okay, not through interpreter, to improve the performance. Got it? So JIT compiler compiles the bytecode of the method to the machine code directly without interference of interpreter. So what is JIT compiler? JIT compiler compiles, write it down, JIT compiler compiles the bytecode of the methods directly to the machine understandable language, without the help of interpreter. Any confusion in this particular point? JIT compiler is a very favorite question in the interview. Okay. Now the details of JRE, right? JRE is what? It's a library, runtime environment, provides the runtime environment, okay, which supplies the required library support to the Java program to run, and also provides the facility of Java virtual machine. Correct? So suppose this is JVM plus libraries, right? This library support and JVM support is provided by, it is called what? The whole thing will be called as Java runtime environment, right? And the both things plus some development tools, some development tools. So these development tools basically the other classes or other libraries to execute that particular program. Okay, to execute that particular program, we will see where these tools are situated. Okay, so this whole thing will be called as JDK. Remember it. JRE consists of JVM plus libraries. And this JRE plus some development tools is equal to JDK, which is called Java Development Kit. Any confusion? ओके, जावा किसी ने इंस्टॉल किया? ओएस क्या है? वो मैक ओएस है कि विंडोज़ है? ओके, क्या एरर? मेरा जो वीडियो मैंने फॉरवर्ड किया उसमें मेरा मैकबुक एयर है, तो आई थिंक द प्रोसेस इज सेम, ठीक है, प्रोसेस इज सेम, बट एरर क्या है? व्हाट आर द एरर यू आर गेटिंग? हाँ, क्या? Eclipse is IDE. Eclipse is IDE. Java is different. Java is JDK. You have to install JDK first. ओके, वो कौन सा शेल है वो देखा क्या? देर आर टू टाइप्स ऑफ शेल बेसिकली, तो उस हिसाब से ये इंस्टॉल करना पड़ेगा. ओके, विल सी. We'll see. I mean, well, huh? Sorry. Delete the previous version or uninstall the previous version and install Java 17, because Java 17 is LTS. LTS means long term support. Okay, long term support means they will expected to give all the supports long term. इतनी जल्दी वो ये नहीं होंगे. फर्स्ट, ओके, सो जावा इंस्टॉलेशन. हाँ, खुशबू, आपका क्या था जावा इंस्टॉलेशन का? विंडोज़ यूज़ कर रहे हो, मैक यूज़ कर रहे हो? विंडो. ऑफिस के लैपटॉप में भी इंस्टॉल हो जाएगा. वो जो मार्केट प्लेस है, मार्केट प्लेस नहीं हो क्या, सॉफ्टवेयर सेंटर, इन्फी का सॉफ्टवेयर सेंटर है, वहाँ पे देखो ऑरेकल का ओपन जेडीके मिल जाएगा. ओपन जेडीके सर्च करो, ठीक है, ओपन जेडीके सर्च करो, उसको इंस्टॉल कर दो, और अकॉर्डिंगली उसका जो जावा पाथ है वो मेरा वीडियो के उधर मैं डिस्कस किया है, उसको सेटअप करो, ठीक है. Before that, what is when I am saying this open JDKs, right? What is that? What are those things? So this is JDK. Okay, this JDK is currently maintained by which company? It's Oracle. Oracle, right? The Java, all the Java systems are maintained by Oracle. Now, any other companies like one thing is Amazon. Amazon has its own JDK. They have customized its JDK. One company is called Azul. Okay, Azul, Zulu. Okay, it's Zulu. Java version is Zulu. Some 17. They have 17, I think. Okay, I am one of the contributor of this Zulu. Okay, Azul company. Then we'll have Oracle open JDK is also there, okay, which is free of cost. Amazon, I have already told Amazon. So these are the companies which are providing the open JDKs. Open JDKs is nothing but JDK which is open source. Open source means no no licensing, but they will have some internal licensing. Okay, otherwise you cannot market your product. Internal licensing. Okay, without this internal licensing or standard, you cannot market your product, or you cannot sell your open JDK in the market. ठीक है. So anyone can download their codes from Oracle site and create their own JDK. Okay, but there is a but if you want to sell those products to other people, or if you want to give those products to other people, you have to have the internal licensing. Okay, or legal process. This is a legal process. Without this legal process, you cannot create the JDK. I mean, you cannot make the JDK buyable, okay, or sellable. So those licensing are getting provided by some companies like what I just told, right? Azul is the one, okay, Oracle is another, Amazon which will have sorry, Amazon which will have some licensing thing, right? All these things, and they're creating their JDKs for their own use, okay, but they're also selling their products, their JDKs, for the rest of the world, okay. So that suppose I am when I am using JDK, I will take it from Azul or Oracle Open JDK, right? I will not create JDK on my own and use it without licensing. That is not done. I mean, that should not be done. You can create JDK, but that JDK will be confined in your machine only. You cannot share that JDK. Got it? Why we need this kind of open JDKs from market? Okay, fine. Now, right now, Java version is around 24. Okay, around 24 is the current version, I think, if I am not wrong. From Java 11, Oracle has decommissioned the JRE folder or JRE portion in the package. Okay, in the JDK package, you will not find in the suppose you are downloading Java 17, or you are downloading Java 14, Java 24, Java 21, you will not find this JRE folder. Earlier, it was used to have a JRE folder, JRE some 1.8.0 underscore 202, that you could find, and inside Java, actually inside Java folder, and one more folder would be JDK, same 1.8.0202, something like that. So currently we will have only JDK folder. Okay, we will have only JDK folder and the build tool, or the development tools, or only tools folder. In this tools folder, all the JRE libraries are there. In this tools folder, all the JRE or runtime environment libraries are there. So there is no separate JRE folder from Java 11. Okay, from Java 11 there will be no separate folder. So right now what you have to install? You have to install JDK only. Correct? So you can find it here. Let me okay, this is a site basically. Okay, so you can, I'm giving you in this chat itself. Where's the chat? Okay, from here suppose you want to get the Java 17. Okay, so here according to your OS, suppose you are using Mac OS, right, Pritham? So according to your configuration, right? According to your configuration, just uh, download this DMG file, okay? And this is a double click solution DMG file, okay? Don't do this installer. It's I mean this is a 64 basically. It's a this will be considered for all the operating system basically. So if your shell is basically SHA 256, it will be installed, no problem. And next is for Khushbu, right? Windows, and according to your according to your configuration, you do this exe file, okay? Exe file, it is a double click solution and pretty straightforward, and in my video I have shown how to set up the Java path, okay, for Windows as well as for Mac OS. So do follow that, and just that will be it's easy, not very tough thing basically. So if you are facing any issue, just let me know, I'll help, no problem. Just try it yourself, otherwise it will take much time in this particular thing, right? So one thing you just observe, whatever you are installing, right? See, it is JDK, okay? You have no other option than JDK. You have to install JDK if you want to use Java. That is because earlier it was used to, you could install JRE or JDK. JRE had some platform support, okay? If you are using, based on your thing, right? Based on your how you are going to use that Java, you could use JRE or JDK. But from Java 11 or Java 11 onwards, you have to install and download and install JDKs only, because JREs are decommissioned. Okay, there is only one component is present, it's JDK, and inside JDK there will be tools which will provide all the libraries. That is basically JRE, Java Runtime Environment. Only thing, everything is same. Only thing, the different अलग फोल्डर बनाया था पहले, वो अलग फोल्डर को उसने हटा दिया, बाकी सब लाइब्रेरीज वो टूल्स नाम के एक फोल्डर में जमा किया है, ट्रांसफर किया है, दैट्स इट. एंड सेम फॉर मैक ओएस. So all the JDKs, right? Same for Linux. Again, all the JDKs. Correct? Okay, fine. Okay, any question? I think for the first day it's enough. Well, basic. You understood, right? Okay. Any problem if you are facing, then just ping me in the WhatsApp. I'll be available. But this concept, I'll share the recordings. Do go through that recordings again and again, and whatever things I have discussed as interview question, right? That is very important. Okay, interview questions, you will be asked those questions. If I am taking your interview, then I will be asking these kind of questions. Okay, fine then. Today that is fine. I don't want to burden more, but from tomorrow we'll take 2 hours class, right? But please make sure that you are installing the Java, otherwise again there will be time waste tomorrow. Hmm? Yeah, try it today. Khushbu, your Infosys laptop will support that JDK. You just have to install it from that software center. Okay, that's just download it. No, and also we will use ID. I will not use. Um, I mean, if I use, suppose I don't prefer Eclipse. Okay, first thing, I'll use some other, some other ID. Okay, for the library support and for inbuilt everything support, I'll guide you. Okay, don't install. If it is installed, this Eclipse is installed, it's fine. We'll install another ID, but for now don't explicitly install Eclipse. Okay. Hmm. Tuesday, Wednesday, Thursday, and Friday. 4 days. So 4 days I have considered, but do you have any problem of 4 days with 4 days? 2 days or 3 days I can take, but the thing is, see, you will lose interest because हाँ प्रैक्टिस प्रैक्टिस अभी क्लास में ही प्रैक्टिस होगा. ओके, क्लास में ही प्रैक्टिस होगा. आई एम स्टॉपिंग द रिकॉर्डिंग.